All right, today's goal is to be able to graph piecewise functions. Piecewise functions are functions with different domains that are pieced together on the same coordinate plane. Typically, they're going to be easier to graph if you use a table of values. You can still use the transformation shift rules that we've talked about, but I think you'll find using a table of values or T-chart is the way to go here. Okay, so let's look at example 1. And we see we have two different pieces of this function. The first function is x plus 3, and then this piece right here represents the domain for x plus 3. And then the second function is negative x squared plus 4, and it has a domain of x is greater than or equal to 1. And again, that's the domain that exists for this piece of the. So what I like to do sometimes on these problems is, especially when there's just two of them, draw a vertical line. I'm going to make it a dashed vertical line at this x coordinate. So at x equals 1, I'm going to draw basically a barrier line that these graphs have to stay on one side or the other of. And first, I'm going to graph the first function, x plus 3. So let's graph y equals x plus 3. And it only exists, so when we graph and make our table of values, it only exists at x equals 1 and values that are less than x equals 1. So I'm going to pick 1, and then I'm going to pick values 2 or 3, x values that are less than 1. We also see that it's x is less than 1 and it's not x is less than or equal to 1. So this implies that when we graph this first coordinate, it's going to be an open dot. All right, so we're going to fill in the T-chart here for y equals x plus 3. So we are just adding 3 to each one of these x values. So that's 4, 3, 2, and 1. So we're going to go and graph those points. Again, notice we have an open dot at 1, 4. But the rest of these can be closed dots because they are not on that dotted line. So this is a diagonal line that's less than 1. Next, we're going to graph our second function, y equals negative x squared plus 4, again using a T-chart, but this time in our T-chart we want a domain that's greater than or equal to 1. So we're going to pick x values that are bigger than 1. And again, since we have the or equal to symbol, it's got to be a solid dot at this first coordinate. So we're just substituting those values in for x, and that's going to give us 3, 0, negative 5, and negative 12. So the first point is at 1, 3. The next point is at 2, 0. 3, negative 5, and 4, negative 12. It was way off the graph here. Now what we have to remember that negative x squared plus 4 is a parabola that's been flipped upside down and shifted up 4. But we're only getting kind of the right-hand side of the vertex. So we do want to make sure that there's a little bit of a curved nature to this graph. And that's it. So let's try one more. Number 2. This one has 3 pieces. So I'm going to start by making my vertical lines in this problem. And this time it appears we're going to have 3 vertical lines. We're going to have one at -4. Again, because that is one of the restrictions on the domain of this graph. We've got -4 mentioned again here, but then we've got +2. Actually, this looks like this will be it. Even though we have 3 functions, we only need 2 vertical lines. See how we've kind of divided this graph into 3 sections, the one on the left, the one on the right, and the one in the middle. So let's take that first function, which is y equals 2x minus 1. And again, here we want the x values that are less than or equal to -4. So in our t-chart, we're going to start at -4. And of course, that's a closed dot at -4 because of the or equal to symbol. And then we're going to pick x values that are less than -4. All right, so then we get -7, -11, -13, -15. A lot of these points we're not going to be able to fit on our graph. That's okay. Really, we only need 2. So I think that's -4, -7, -5, -11. Just going to have to estimate. And since this is a linear graph, so all we really need is 2 points. That should be a straight line. See if I can do that a little better. There we go. All right, and then I'm going to use a different color for that middle function. That's not required, but it's just helpful. The middle function is just y equals 2. And this one has a restricted domain from -4 to +2. So we could actually plot all of these points. It wants just the x values that are in that range. And since this equation is the equation y equals 2, it doesn't matter what the x coordinate is. This, of course, is just going to be a horizontal line. And remember, we've got open dots because this did not have the or equal to symbol. All right. And then lastly, let's graph. We've got a square root function, square root of x plus 2 minus 1. And let's look at our restricted domain. Our restricted domain is x is greater than or equal to 2. So we're going to do a 2. We're going to do a closed dot at 2. And then just pick a couple of x values that are greater than 2. Okay, there's some of the points. I know I said usually we don't want decimals, but I'm going to go ahead and graph a couple of decimals here just to get a few more points. The square root of 5 minus 1 is approximately 1.2. Square root of 6 minus 1 is approximately 1.4. And the square root of 7 minus 1 is approximately 1.6. So again, I'm going to graph a couple of those points. Remember, there's a closed dot at 2, 3. Uh-oh, I've got a mistake somewhere. Oh, and I see it. Instead of 2, 3, square root of 4 is 2, minus 1 should be 1. So I had a couple little mistakes there. The thing you got to remember about this function is it's not quite just a line, but it's a square root function, so there's a little bit of a curvature to it. If you think about that, this one was originally shifted down 1 and left 2, so we're not really seeing the beginning of this graph. So that's kind of why it looks so flat.